Well, wonderful presentations. Thank you very much for that. I'm going to start off by asking my own question, and then Jason's going to go over to Slido and select that. And thanks everyone. A lot of great interest right now on Slido with a lot of questions. So one of the things that struck me listening to all three of you was just the concept that you brought forward, Colin, around the river only needs one channel. And it made me start to think about that. That's a concept that really still holds true today in the people that I talk with, and I constantly hear from people, they have a disturbance in their backyard. They're like, let's just make it, I want the restoration to just make it like it was before, which is the old concept that you were talking about, the river only needs one channel. And so, and it's not really addressing the zero stage concept at all by making it what it was back before, because we're thinking that one channel thinking. And so Janine, I know, I picked up that you talked about being willing to experiment, to just try things to make things better. And Paul, you had initial memories of jumping in and wanting to fix it right away, and going back to the making it what it was before concept, I think is where you were. And so my question to you, or more my interest, is to hear your points of view now that where you are right now, how you would respond to when you hear people say to you, I just want to make it like it was before. What would you say? And maybe I'll just leave it open, and you could all or one of you just talk whatever you wish. Or nobody can talk.
All right,
Well,
I'll take a
I'll
shot. Looks
start
like
if nobody else is going to.
you do it, Colin.
Okay. Yeah, I think there's a danger in yearning for the past, um, because the rivers of the past are not necessarily going to be appropriate as the rivers of the future. And the idea of restoring to stage zero isn't to try and resuscitate rivers that no longer exist. It's something rather different, and it's been termed in various ways as a Control Alt Delete or a valley floor reset. And often that is the case, although it doesn't always have to be, the makeover doesn't have to be that extreme sometimes, and we'll hear more about that from Jared in a few minutes. But the concept is not going back, but if you like, going back to the future, in as much as we don't expect the river to stay the way that it is after it's been restored to stage zero. We expect the opposite, for it to continue to evolve. And in terms of restoration design, we have to remember that nature doesn't design channels. Natural channels evolve. They're the outcome of everything that's ever happened to them, and they must be adaptive and responsive to new impacts and new changes that are coming in the future that are not just uncertain, they're unknowable because they haven't happened yet. We're heading for novel hydrologies and ecologies that haven't been seen in the particular geographical locations. And what we're doing with the valley floor reset, or the Control Alt Delete, clearing out all of the accumulated changes that people have made to these valleys, what we're doing there is setting the river up to be responsive and resilient to whatever the future may throw at them, given that future is very, very uncertain. So I don't know if that's really answering your question, but the aim is to remove constraints, remove redundant infrastructure, and then trust natural processes to make the river the best river it can be under the circumstances that pertain, under the flow regimes and the drought regimes and the land use change regimes that come with the future, rather than trying to design or impose a form and a process pallet on a river when we don't know, we can't design, we can't know what the appropriate design would be.
I found that very helpful. I'm not sure if Janine or Paul want to jump in, but what I'll pick up from your comment, Colin, is that we need to communicate with the public around the dynamic nature of river systems and the need to allow those systems the time and space to become what they want to be.
Yeah,
I'll add
on. I mean, rivers don't want to be anything. They'll be what they are, based on the balance of the influences of geology, hydrology, and particularly biology. And I don't think we can do better than that.
Thank you. Over to you, Jason.
Or was Paul going to offer a comment on that?
I was going to, just one thing, and maybe I was hearing the question slightly different, but when you mentioned putting the river back the way it was, maybe I was envisioning a little shorter time ago when you see lateral erosions and things like, I think a lot of times people want the river, if you're talking to a private landowner, maybe the river back where it was, meaning where it was convenient. So back to like that River Alla example, maybe having it in that ditched alignment and a simple road crossing is most convenient, and it makes that ag land available for utilization. Versus, if we think about that landscape from the same lens that Colin's talking about, and letting the river be a river and function and process at the appropriate scale, there's larger benefits to humans as well in letting that river flood and deposit and work within the boundaries that it used to. So I think sometimes it's re-looking at the immediate needs and the short-term needs versus of humans versus the longer term, and how do we fit into this context as well, maybe.
And I can add maybe one more comment. I would be remiss if I didn't answer this from the fisheries perspective. And I guess the way I look at this is, if we think about rivers and streams as lines on a map, as very linear features, I guess my supposition is there is not enough habitat out there for the recovery of salmon and steelhead and bull trout and all the other aquatic species dependent on them. We need floodplains. They need to be connected, because that is fish habitat. That's aquatic habitat. That's why we're thinking about these systems more three-dimensionally rather than one-dimensionally. So I think when we're talking particularly about fisheries, this is a very important concept. We don't need connected floodplains everywhere, but we do need enough within the basin to sustain fisheries, other aquatic species in these aquatic systems.
All right, well, thank you for that. That was a nice way to get into our discussion, our Q&A session, wrapping up from the morning presentations. I'm not sure, as presenters who are sitting there remotely, if you can see all the Slido questions on the side. Can you see them? Okay. I think.
Now I can.
Okay, Dale and I will sort of take some moderator's prerogative and pick from these. And there's a whole bunch also in the queue for people that are putting questions in. We're just trying not to have this screen kind of operating like an annoying ticker tape on the evening news, and sort of have questions come up in a reasonably moderated flow. So there's one here attributed to Jordan. I don't know which Jordan this might be, but it was at the top of the queue for a bit. It's, how do you target specific restoration? Oh, Colin, moving on, thank you. How do you target specific restoration sites, since most degraded areas run through developed or agricultural or private land? What I mean is, how do we make landowners amenable to restoration and the creation of floodplain on their land? And I would even just expand that to whether it's landowners or government entities or development entities. How do you take this idea, which maybe to people who look at the world through a fish lens, a salmon lens, or an ecosystem lens, and where you don't have lands that are maybe controlled by a benevolent entity that's interested in your objectives, how do you move it forward?
I'll start off with this one and maybe request that Paul and Colin jump in. What has worked really well for me is, we talk about in the West, well, we don't have enough space, we don't have enough land. They're doing this in many places in the UK where things are much more constricted. And this gets back to my comment about we don't need these connected floodplains everywhere. And in many cases, we don't need the entire floodplain. So I think what we have been doing to date is fairly opportunistic, where we have a willing landowner, where we have the space, and every one of these projects that I've worked on has either been in ownership of a land trust or in federal land, state land, or there's been an easement. So I don't think as we start into these types of projects, we should be trying to get landowners to kind of give up a whole bunch of land. Um, Honestly, we don't have enough restoration money to do that anyhow, to kind of go out every place that there's a potential and do these projects. So I think it's really critical that we choose willing partners who will engage to start doing these projects. And then over time, I think more people will come on board.
Thanks, Janine.
Yeah.
Colin or Paul, would you like to comment on that?
Yeah, I'll add that it's no coincidence, I don't think, that a lot of that evolution that Janine shared was on federal lands. We do have the land ownership where we have, in particular, that geomorphic control that I mentioned. That really is the start and end of everything. If we're going to restore a project, that's a necessity. And so when you have one large landowner, that's relatively easy to do. But as Janine says, as these projects have been on the ground, I think that the neighboring private landowners are now coming to us and saying, can we get this same stuff on our ground? And then that's where you start to develop this collaborative, landscape scale approach to where we incorporate the geomorphic control, and we have enough of the valley brought back into play where we can actually restore the processes. So I think for us, that's been a pretty effective means where we have the demonstration projects on the federally managed grounds, and then the private folks are coming to us asking for it, versus the flip side of me knocking on the door and saying, hey, have I got a great idea for you?
Okay, maybe
just a bit on my experience in mid Wales. There's one particular valley where there's a valley cooperative of landowners, predominantly sheep farmers, who really understand how their farms, how the quality of their farms has been degraded over the years. And they're all, getting on towards my age, and they want to leave a better legacy for the people who will inherit their farms, because they realize that they're not as productive as they used to be, primarily because they're dried out, they're just over drained. And so that farmers cooperative came forward and asked for help on how to rehydrate their floodplains, starting with areas that were pretty difficult to manage anyway, because they tended to be boggy and the tractor got stuck often, and areas that the pasture was just not good enough anymore to support the stocking densities that it did in the past. So they appreciated the value of ecosystem services and hydrated landscapes, but they're really also interested in the bottom line. They don't want to go out of business, and they don't want to stop farming, and they don't want the land rewilded, but they do want it to be as productive as it used to be. And that's where these valley wetland floodplain systems support huge primary productivity. And that's what puts energy back into the landscape and the ecosystem, and that's what makes your sheep fat and your cows happy. So very often there isn't a conflict of interest between ranchers and farmers and floodplain reconnection. There's actually a common goal there of just making these areas more productive like they used to be before we took out more than nature could put back and ran them into the ground. And this is something I think that landowners who've been on the land for a long time, they don't suffer so much from the shifting base level. They are old enough to remember how it was 50 years ago, and realize how quickly that great legacy of nature has been expended, and recognise that we need to resuscitate it. We need to get back. We need to give the land a chance to support the agriculture and the ranching that we want to take on.
Thank you for that. This next question really focuses around sequencing in my mind. And, in British Columbia, we have a lot of interest in salmon population stocks, the critical nature that they're currently in. And so the question is around when infilling channels to return to zero stage, how do you minimize impacts to migrating fish during the transition years? There is concern you could be disrupting stocks over multiple years. Anybody want to jump in on that question?
Janine, you want that one first?
I thought you were going to answer that one. I will make a short comment while you're gathering your thoughts about that. Quite frankly, this has been one of the biggest concerns, biggest issues that we hear from the fisheries biologists from both our federal and state agencies on how are the fish going to get through, how are they going to migrate. And what we've seen from experience is that the fish are coming up into these areas oftentimes right after construction. There are multiple channels. It gives them lots of different options of where they can go. A lot of times they're hanging out in that area. And I think the best way to handle it, quite frankly, we've done some pit tagging on fish, monitored their movement, had contingency plans in place if we lose passage. And I think for these kind of newer projects and experiments, having a contingency to reassure folks that we aren't going to let the fish kind of come up and get stuck and not move upstream. But from experience, we have seen that is not nearly the issue that folks were worried about. So I'll hand it to Paul.
Oh, I know I can find them.
You said that very well. I think pretty much every single project with anadromous fish, that's been a primary concern people have. And it's, I think we have this idea that if we take the water out of the channel and just let it be distributed amongst multiple channels, that there's not enough water available to fill those channels and provide the depth for passage. And we find that that's not the case. It's a matter of the velocity of water in those channels. When it's in a single channel and channelized, our velocities are high, and there's not very much depth, and that water moves past and through the landscape very quickly. Versus when we're fully connected to the valley, like we're talking about, our mean velocities are much, much slower. So our residence time for that water is a lot greater. And actually our mean depths are higher post-project than they were pre-project. So the fish passage turns out to be not an issue on them. And like Janine said, you think of species like Chinook, they've been evolving with disturbance, landslides, floods, fires, volcanoes, all the things that we have in the Pacific Northwest, and they thrive in those. So the adult Chinook show up very quickly, right on our heels, start to spawn pretty quickly. And then really it's, when you think about the evolution of the species, or not the evolution, but the use of the Chinook on these landscapes, it's more the rearing habitat that's lost. When we think about these single thread channels that are efficient at moving sediment, they're also efficient at moving out that water and the nutrients, and the juvenile fish try and make a living in there, versus in that, again, lower energy environment that's fully connected. It's a very food rich environment. They're not burning a lot of calories to grow, and so they grow faster, larger. It's a better rearing environment for the juvenile fish as well.
Great, thank you for that. Jason?
All right, I'm going to restore a question. I think we archived it for a minute because we thought maybe it was a bit of a follow or a parallel to one we'd already asked, but it's at the top of the queue here. A lot of the habitat in British Columbia is stuck in stages 3 or 4 due to agricultural development, urbanization, other kinds of valley bottom development. And it's often coupled with dikes. And so what advice do you have for getting somewhere close to stage 0 in these places where your space is limited and constrained? And if you could just write that down in 2 sentences so we can get on with it, that would be perfect.
Well, I'd respond by saying that the thing is, if you can't get the full floodplain back, then work with what you've got. There probably is a minimum width of Brian Clew would call it process space, or if you like, river wetland floodplain corridor width that you need, but it's unlikely to be the full width of the valley, valley wall to valley wall. The river can adapt and make best use of whatever space you give it. And there are some terrific floodplain reconnection projects both in Portland and in England, in pretty urban landscapes. And what's happening there basically is a stage 8 restoration rather than a stage 0. So you've got the incised channel, you've got an inset proto floodplain, and you just make best use of that, recognizing that the old floodplain, which is now a terrace, is no longer accessible to you. And in the presentation this afternoon, where we look at case studies, I can actually pop in, if Derek and Amy will let me, add a couple more slides still, specific to those projects in Portland and Northern Ireland, where some very nice floodplain wetland corridors have been reconnected within urban areas through a stage 8 restoration, rather than trying to get back to stage 0.
Yeah, go ahead.
So I'd like to add just a little bit more onto that, very specifically about width. This has been a huge question, like how much space do we need? And we have some anecdotal information from the engineers about how much space we need. So for those of you out there who are designers and you think about putting in a bridge or a culvert, we find that when that floodplain width gets to about 6 times the channel width, we start thinking about putting in flood relief culverts through our road fill. And so we know somewhere between maybe 6 to 10 times the channel width, we start getting to the point where we could support multiple channels. There hasn't been a lot of research on this. Again, this is more anecdotal, but I think at about 10 times channel width, you could start thinking about doing more of a stage 0 or a stage 8 project. You can go through the calculations. What we want to avoid is a situation where we have a transport channel some of the time that flips to a depositional channel and it flips back and forth, because then what happens is you can have stripping of that floodplain surface. So you need to make sure there's enough space, velocities are staying low enough that it can sustain a floodplain, and we do have the design tools to help answer that question. If you don't have the space, don't try doing the project. That would be my advice.
And Paul, did you have a comment on that? If not, I have a follow-up for you specifically.
I'll add just real briefly, and I think Janine and Colin said it very well, and we are working on some, and again, they're stage 8 type projects on large rivers. Right now on the McKenzie River, transitioning a former gravel quarry right there alongside the river into a connected stage 8 river valley. So it's kind of a hybrid of we can't get back to what the McKenzie was, and we still need a boating channel and all that stuff. So that main stem trunk line still exists, but then we've brought the, basically this area that's been written off and left as a blackberry patch back into active fluvial process space for the river.
Okay, well, that's been helpful. It did lead me to kind of a follow-on question that came from a couple of the slides in your presentation, Paul. Your anecdote around here's the eroding bank, that's what always brought me here. I think it was one of your opening slides. I've probably got 100 spots like that I drive past on a bi-weekly basis. And I've spent, I will say, a lot of time working on things that kind of look like, well, we don't want that to keep happening. Let's work on the bank. Is there ever a time you do that? And I'm not saying, I don't believe this stage 0 stuff, but as a follow-on to that question, you might not always have the ability to kind of look at it from let's restore natural process and work on the floodplain reconnectivity. Do you ever just go to that eroding bank and say, well, it's the best we can do here?
Yeah, great question. So yeah, that was probably the first 10, 15 years of my career was doing exactly that. And that's kind of what took us down that path that Janine described for us so well is we were thinking of that eroding bank as being a pollutant. Basically, there's sediment coming out of that, and we're degrading water quality by letting those sediments erode into the channel and such. Versus now, I haven't since probably the early 2000s have not done that. And man, I can't think of a good example. What keeps coming to my mind now is that rather than thinking of that sediment as a pollutant, I think of most of our river channels that we're working in are so efficient and they're moving so much sediment out that I think the river needs some of those sources. And even within our stage 8 and stage 0 projects, I think having some spots that are in the short term easily erodible and letting that sediment move back and forth within the project space can be extremely beneficial. So sorry to answer your question so poorly. I can't think of an example. And unless you're right against infrastructure, a bridge crossing or something where you have to have the road cross and not be taken out. So I can't think of a good example for you.
No, I wouldn't. I would say that's the opposite of a poor answer. It's a thought-provoking one, and I don't want to monopolize the conversation, but just to make sure I understood it right, if it were up to you, using the example from your slideshow, you would see it as a better option to leave it and let it erode, if that's an option, as opposed to coming in and doing some kind of semi-naturalized log treatment type structure, out of a restoration technical manual or something like that.
Yeah, so for that first example that I used, what we would be doing now is step one is to get that geomorphic control reestablished. So that's where you're going to bring in your heavy equipment, the bulldozers, excavators and stuff, and move that glacial material, that non-erodible material that formed that valley in the first place. We're going to get that material back in place and bring that back up to our elevations prior to the incision. And now upstream of that, where we're in that response valley, where we're going to get the deposition going again, I think when people think about deposition and how that restores, they look at the particles in the bed, and you're largely going to see gravels and cobbles and maybe even the glacial material, versus what I'm looking at is the bank profile. I want to see what this valley's been constructed out of for the past 8,000 years after the glaciers left. And like we saw in that picture, it's not bed load, it's suspended sediment, and it's ash, and it's the volcanic eruptions and things of that nature. So that's what I'm going to be trying to capture in recovering this valley. And so within that entrenched valley, you're going to get two things going on. By putting that geomorphic control back in place, we're going to cause the water in that low gradient valley headward to backwater and kind of get that lake effect, right? So now it's much less efficient at transporting that suspended sediment. And then from there, we've got options. We can mechanically refill that incised channel that currently exists, or we can put in log jams, or we can use, like Jared and Damien are going to share with us, those beaver mimicry structures, obstructions and hardness within the river valley and within that flow path, things that are going to cause the suspended sediments to fall out around those roughness elements and lift and fill that riverbed back up to the valley. And then, like Janine mentioned, it's really about the groundwater, bringing that valley wide all the way back up to that valley surface. And then biology becomes the driving element that takes over the evolution of that valley from that point forward.
All right, thanks for that. Ginny, I see you've got a comment, and you too, Colin. I'm happy to let you guys talk, and then I'll turn it back over to Dale. So go ahead, Ginny.
Just as a follow-on to that, the first decade of my career, I worked for the Natural Resources Conservation Service, and I did bank stabilization work, working with private landowners on exactly these situations. And to kind of come back to that question, if you're in a stage 3, 4, you have to really question, are you keeping the stream in a more unstable state by putting in some sort of bank protection, whether it be wood or rock? What you can do is figure out how much space do you need, looking at the reaches maybe downstream to see how wide the channel is, and talking to the landowner saying, we understand that you want to protect your bank, but if you allow this to evolve through time, it's only going to erode another 20 feet or 10 feet. And oftentimes it's not economically feasible to do that stabilization work. My other point is, for the work that I'm involved in now in restoration, we don't spend restoration dollars stabilizing stream banks. I think there's a differentiation of if you're in a transport reach and you have infrastructure that has to be protected, it's just recognizing, just keep it a transport reach, make sure it's passable, it's got enough roughness in there, a lot of things that Paul talked about. But I think really looking at the stream evolution model to see where it's at and where you're going to kind of lock it into place, and why perhaps putting the stabilization on the edge of the floodplain, even if it's small, is a heck of a lot better than putting it on the bank.
Great. Thanks, Janine. Colin?
Yeah, Janine pretty much said what I was going to say. The thing I would add, and I've worked on bank protection a lot, is that whatever decision you make, it must be risk-based. You know, if you've got a nuclear power station that's at risk, well, you have to minimize the risk because the probability of erosion, because the consequences are catastrophic. If it's a soybean field, not so much. And the danger with just doing bank protection willy-nilly is it was illustrated a few years ago in Mississippi, where a demonstration project was done on a farmer's field, not because the cost-benefit analysis justified it, but just to show how you could stabilize a bank using a mixture of hard structural means together with bioengineering. Stabilizing that bank caused the failure of a county road bridge just downstream, because the energy of the stream was redirected from eroding that bank to scouring out the bed, and the bridge collapsed. That wasn't good engineering, and it was really bad decision making. So I think, you know, protecting stream banks must be risk based. If the risks are high, then you maybe can't afford to take any chances with bioengineered schemes, and you have to use riprap or shell piles. But if the risk is low, or the cost benefit is negative, then we shouldn't be hardening riverbanks.
All right. Well, thank you. Thanks for indulging my my extended question there, but I'll turn it back to Dale. We've probably got time for one more before break.
Sure. I'm used to Jason taking the mic and going on, so it wasn't a surprise to me. I'm going to ask this question here, and it's really, I think, reflective of the conditions that we're seeing in BC around, obviously the changing climate that we're having, the atmospheric rivers that we now call them. We used to call them heavy rains, but now they're atmospheric rivers. And just the extensive logging that's going on, in part with the extensive fires that we've been having over the last 10-year period. And so the question is really around, I guess, a typical strategy to improve floodplain connectivity, where these major changing conditions are happening. And maybe it's given that we're in this state, what are some of your initial thinking that we should be applying when trying to advance restoration or advance connectivity? Okay, I know, Janine, you're just dying to jump in there.
I was dying to say, this is clearly Colin's topic. But before I hand it to Colin, I'm going to make a somewhat of a different comment, because this is one of the big surprises for us. I think those of us doing the stage 0 restoration work, there is a project in Oregon, full connectivity, groundwater close to the surface, and during one of the wildfires completely burned over. And so one of the things with climate change we're seeing are these stage 0 projects, these areas with connectivity, providing refuges out there, because the roots aren't burning. So a lot of times in these wildfires, very intense wildfires, the roots of the vegetation actually burn. And in the areas where groundwater is close to the surface, these are kind of almost wildfire refuge areas. And there's more information coming out about this, and there will be some papers being published hopefully in the near future. But I'm going to pass it back to Colin about the actual flood risk part of it, because that is clearly his area.
Sure, I've worked a lot on flood risk management, and my feeling on this is that we have to be very clear in differentiating flood vulnerable areas from flood suitable areas, because at the moment seem to want to try to protect everywhere from flooding, and demonstrably we can't do that. Now, if you have infrastructure, people's homes, people's businesses, people's livelihoods at risk, then flood protection is entirely appropriate. But in fact, that's probably going to be a relatively small percentage of the watershed or catchment area when you actually look at it on the map. And in many other places, and river wetland corridors are a prime example, they are flood suitable. The flood hazard there is them not getting flooded enough. And so my take on this is that future flood risk management will have a lot less flood management and a lot more managed flooding, where we increase the opportunities and the probabilities and the frequencies of flooding in flood suitable areas like river wetland floodplain corridors in order to take pressure off flood vulnerable areas like cities and developed areas of the floodplain.
Yeah, thank you very much for that. Colin?
I'll tack on one
go
tiny
ahead,
bit.
Paul. Yeah, go ahead, Paul.
I won't speak nearly as well as those two, but I'll let, and Janine hit on this a bit with that project. I think a really nice thing about these projects is how they turn pretty much everything we think about rivers on their head, and they're the opposite. It's backwards day when you're working with these projects. And so those things that you just listed off that we would view, when I was building single thread channels and designing those, you'd view them as catastrophic. The massive floods, the wildfires, things of that nature, things that are a threat to your channel with the single thread channel actually turn into beneficial pieces for the Stage River Valley. The fire is not going to burn up the Stage Zero Valley, but it does mobilize woody material, nutrients, and things like that from the uplands, which now, when it's mobilized, is going to be deposited on that Stage Zero Valley. So it's increasing the richness in how much materials are being delivered to that area where they can actually park instead of being just simply transported through. And similar with floods. Floods don't tear them apart. Floods just bring more of the goodness that makes that valley so good to begin with.
Thank you for that, Paul. I want to thank Colin and Janine and Paul for their presentations and going through these questions. There is a whole lot more questions that we obviously are not getting to, but at this point in our agenda, we're going to take a short break to 10:45, and then we're going to come back with our next presenter. So 10:45, please do what you need to and then come back.